Okay, so in this tutorial video, I will introduce the root test. So the root test is a very powerful test that can help us check whether a given series is convergent or divergent. Okay, so the test is set into this. We have a series in here, and then this can be any series. Okay, so be any series, and suppose that when we take a limit as n goes to infinity, the nth root of the absolute value of the en equals capital L. Okay, and we're gonna have 3 parts. So the root test, the conclusion is identical to the ratio test. The first one is if capital L is less than 1, knowing that our capital L, it must be greater or equal than 0. So if capital L is less than 1, then the series En is absolute convergent. Okay, absolutely convergent. 2, if capital L is greater than 1, then the series diverges. Okay, and then 3, if capital L equals 1, then the test is inconclusive. That means when capital L equals 1, we cannot get any conclusion from the root test. So we need to give a try to another test to see whether we can figure the problem out or not. Okay, so this is the root test. So very useful. So right now, let us take a look at a couple of examples here. Okay, so first example, let's see this. So we have a series. So series with an equals n over 2 to the power n if our n is odd. Okay, for example, n is 1, 3, 5, etc. And then I have 1 over 2 to the power n when my n is even. Okay, is even. So the question is, the question here, converge or not? Okay. Or not. So you can see that here we have n over 2 to the power n, and we have 1 over 2 to the power n here. So the root test, after we apply, you will see that there will be a large amount of cancellation getting involved. Okay, so it turns out that if we apply the root test, so apply root test, and then that is I'm gonna apply the nth root of this absolute value of an. Turns out I'm gonna have this. I'm gonna have the nth root of n over 2, when n is odd. And I also have the 1 over 2 when n is even. Okay, when n is even. And therefore, as you can see that the nth root of absolute value of an is actually it's greater or equal than 1 over 2, right? Because you only have those two values, and less or equal than the nth root of n over 2 here. Okay, and the limit as n goes to infinity, the nth root of n actually equals 1. Okay, equals 1. So if we take the limit as n goes to infinity on both sides, okay, that is limit n goes to infinity, the nth root of absolute value of an. So this part is a constant. We're good. And then as you can see that it will also less or equal than limit as n goes to infinity, nth root of n over 2, which is going to be 1 over 2. Okay. And as we know that, this limit is greater or equal than half and less or equal than half. So based on the sandwich theorem, we introduced this in the class of Calculus 1. And it turns out that this limit as n goes to infinity, the nth root of an is going to be 1 over 2. Okay, so since this 1 over 2 is less than 1, and then based on the root test, we know that our series actually is converged, right? It not only converges, but it's converges absolutely. Okay. So based on the root test, series converges absolutely. Okay. So keep in mind that converges absolutely is a strong convergent than regular converge. Okay. So if it's converges absolutely, it's definitely gonna converge. Okay. So I hope you enjoyed this short video, and thank you for watching.